All right, so let's get right into it. We're looking at this really extraordinary sequence of early winter weather that's just slamming North America.
It's quite a setup.
Yeah, our mission today is to do a deep dive into what happens when these severe events hit back-to-back, with basically no recovery time. Going from a blizzard to a bomb cyclone and then into a brutal Arctic deep freeze.
A three-punch knockout is the right way to put it.
It really is. And the key phrase here is an unusually progressive pattern. We've already had Winter Storm Bellamy, which, shut down Chicago O'Hare with hundreds of cancellations.
Knocked a foot of snow in some places.
Exactly. And now Winter Storm Chan is moving in, sort of paving the way for the main event, this explosive nor'easter. And the big takeaway is that there's no operational lag. Crews can't reset before the next thing hits.
And that second punch, that nor'easter, the meteorological energy being unleashed there is just fascinating. It's forecast to meet the technical criteria for bombogenesis.
Okay, bombogenesis. I've been hearing that term. So break that down for us. What does that actually mean?
I mean, it's an explosive intensification. It means the storm's central pressure is expected to drop by at least 24 millibars in just 24 hours. That's incredibly rapid.
So why now? Why is the atmosphere organizing itself so efficiently to create that kind of bomb?
It's really a perfect alignment of what we call the storm ingredient checklist. The main driver is the maximization of the baroclinic zone.
Right.
Think of it like a high-powered atmospheric fault line.
Yeah.
You have this exceptionally warm, moist air from the Gulf being pulled right into the path of that massive, frigid Arctic air mass we already have in place.
So that extreme temperature difference is the engine.
Exactly, that's the engine. And then the warm water of the Gulf Stream acts like a fuel injection, just supercharging the whole system.
Wow. So with that much energy, where's the absolute worst of it going to hit?
Unfortunately, the highest severity looks to be aimed squarely at Atlantic Canada. We're talking Nova Scotia and Newfoundland.
And what are they looking at?
Projections are showing catastrophic conditions, up to 91 centimeters, that's 2 to 3 feet of snow. And that's accompanied by sustained hurricane-force winds and these dangerously high waves, maybe 7 to 8 meters.
That's just devastating. What does that mean for the U.S. coast then? Places like D.C. or Boston?
Well, that's the critical challenge. There's so much uncertainty in the track. If that storm center shifts by just 50 miles, you could see major cities go from a heavy rain event to a crippling mixed precipitation disaster.
So planners have to assume the worst-case scenario.
They absolutely must. You have to plan for that high-end scenario.
Okay, so that covers the storm. But what about this deep, prolonged cold that follows? This deep freeze is driven by something else entirely, right?
Higher up. Exactly. Now we have to look up into the stratosphere. The genesis of this prolonged cold is an unusually early and pretty substantial destabilization of the polar vortex.
The polar vortex. And I saw some chatter about a potential, sudden stratospheric warming event?
That's right. Forecasters are monitoring it. It's rare for November, but it's on the table.
Okay, that sounds really dense. What does a sudden stratospheric warming actually mean for the temperatures we feel down here on the ground?
So you can think of the polar vortex as a stable, fast-spinning top that keeps all the coldest air locked up around the Arctic.
Right, it contains it.
It contains it. But a sudden stratospheric warming, or SSW, is when the air way up high in the stratosphere heats up rapidly. That causes the spinning top to wobble violently and, it breaks down.
And when it breaks down, it unleashes all that frigid air.
Precisely. It pushes these massive, dense lobes of Arctic air way south, deep into our latitudes. And that's why we're seeing temperatures forecast 20 to 30 degrees Fahrenheit below normal.
That's a huge departure from normal.
It is. The intensity is comparable to some major outbreaks we've seen in the past, but the timing, the fact that it's this early, that's what increases the vulnerability.
And it's not just the northern states, right? This goes far south.
It does. While Canada is going to see life-threatening wind chills, minus 25 to minus 35 Celsius in Montreal and Quebec City, the really acute risk is how deep this cold penetrates into the south. Florida, the Gulf states.
Because their infrastructure just isn't built for that.
Not at all. Water utilities, plumbing, agriculture. It's just not designed to withstand a sustained deep freeze.
So if you put it all together, you have the high wind and snow damage from the nor'easter, and then immediately following it,
you get this massive surge in energy demand from the Arctic cold. It creates a peak, multi-sector operational challenge. It's a nightmare scenario.
So what does this tell us about the rest of the winter? Is this a one-off?
I don't think so. The thing is, this early and substantial disruption of the polar vortex, it's a signal. It indicates a highly volatile winter is ahead of us. This whole sequence really sets the stage for what could be a truly cold Canadian winter, with a high probability of more severe cold waves and storms coming our way into the new year.
Knowledge that definitely helps you prepare for what's coming. That was our deep dive.